Let's make sure it's recording. Yes, it is. Great. Good morning, everyone. So I hope you had a good weekend. So let's start with a few announcements. So section 2.4 is not going to be covered in the midterm and finals. Okay? So the epsilon and delta business, you can forget about that. Very good. Anyway. Okay. Great. I mean, if you practice exercises, then it's good for you. You know, yeah, if you did some exercises, it's good for you. It's not going to hurt you. So, very good. Okay. Are we all good? Awesome. Great. Now, let's continue doing more problems on this trigonometric limit business. Should we do more examples of these trig limits, or it's good? We could do one or two more. Let's see. Using the fact that what is the value of this limit? 1. Oh, by the way, the second work is open as well. Okay? Yeah, second work is open. Find the value of what? Let's see. Let us try these two things. And let us try to find these two limits using the fact that sine h over h equals to 1 when h approaches 0. Now we know that this thing, what does it approach? 0, right? I mean, let's prove this using sine h over h, and let's find this limit. Great. Now, what do you suggest doing for the first one? How do you prove the first one? What do you get? 0 over 0. The first, the first one, the answer we know is 0, but let's show this now. What is it? How do I proceed here? In the back, yeah? That's a very good point. So I want to try to let the sign of something over the same something, right? That's what I want to try. Very good point. Very good point. Very good point. Now, what do you know about the trig formulas? Do you remember the trig formulas? What is cosine of 2a? Cosine of 2a is, what is that? It's 1 minus 2 sine squared a, right? Do you guys remember that or not? Yes. And this is 2 cos squared a minus 1, and it's equal to cos squared a minus sine squared a. Right? You guys remember these three formulas? Great. Now, what is cos h minus 1 over h? If I let my a to be equal to h over 2, cos h minus 1, what would that be equal to? This would be equal to limit as h approaches 0. Cos h minus 1 would be equal to minus 2 sine squared h over 2 over h. Agree or not? Yes or no? Everybody? Just let a be equal to h over 2. Okay? Apply this formula with a equal h over 2. And write down. So if a is equal to h over 2, what do I get? I get cosine 2a. What is 2a? Is h. Right? Is 1 minus 2 sine squared h over 2. Great. Now how do I proceed? me, oops, yeah, okay, very good. This is equal to the limit. Is the minus 2 bothering me? Is it bothering me? Oh shoot, did I mess it up? Maybe I don't think, is that doable here actually? Let me double, no, that's fine, that's fine, that's fine. Yeah, no, that's fine, that's fine, that's fine, that's fine, yeah. Let me write it this way. Okay, if I wrote it this way, does it help me or not? It kind of helps me, right? Do you guys see that? I still have a 0 over 0, but let me do one more thing. I divide this h by 2, and I multiply it by 2. You guys see this? Great. So let me cancel these two out. And what do I get? I get sine h over 2 over h over 2 times sine h over 2. I think I put the minus sign. And that's what I get. Agreed? Everybody? Great. What is the limit of sine h over 2 as h goes to 0? 0, right? This is sine of 0. What is this limit as h goes to 0? 1. So what is my answer? It's minus 1 times 0. Do you guys see this? Yeah? Is equal to minus 1 times 0, which is 0, since this is just the limit clause. Okay, are we good here? Any questions on this? Any questions? So far so good? Yeah? Is there any mistake? Okay, are we good here? Okay, let's do one more. Any questions on this part, please? Yes. Oh, this is just from the double angle or half angle or double angle formula. Right? What do you mean? In what case? In the first step? Here.
I understand why you took the double angle formula, but why h over 2?
Oh, your 2a is equal to h. Right? So cosine h minus 1 is cosine of 2a minus 1. Right? Your 2a is equal to h. What is your a equal to? Okay? Great. Now we have one more. Limit as h approaches 0 of cos h minus 1 over h squared, sorry. I try to plug in first of all. What do I get? I get a 0 over 0 in determinate form. Let us do the same trick there. So cos h minus 1 over h squared, what is that? This is minus 2 sine squared h over 2 over h squared. Then what is this? Let's do that. How do I proceed here? Let me just expand, no, well, not expand, but write the sine h over 2 in this way, sine squared h over 2 in this way, so just sine h over 2 times sine h over 2 over h times h, right? You guys see this? Yeah. Now what do I need to do here? Yeah. The square root of the top. Just no, but I mean, before at some point we're going to have to do some sort of square root or some square, right? But yeah, it's good. But before I take any sort of in order to use my theorem, how do I apply that? How do I apply that? Yep.
Just 2h over 2 times 2h over 2.
Exactly. Thank you very much. So I divide this h by 2, and I multiply by 2. And I divide this h by 2, and I multiply by 2. Thank you. So what do I get? It's minus 2 times 2, what is that? This is 4, right? And then I get sine h over 2 over h over 2, and sine h over 2 over h over 2. What is this limit?
Negative 1/2.
Negative 1/2. Do we see that? Do we all see that? Everybody, do we see that? Sine h over 2 over h over 2, where does it go to? 1. Sine h over 2 over h over 2, where does it go to? 1. Minus 2 over 4, what is that? Minus 1/2. Minus 1/2. Let's justify here. Well, it's the same justification as here. Let's rewrite it. Since limit as h goes to 0 of h over 2 is 0, and the limit as, I don't know, theta goes to 0 of sine theta over theta. Okay, great. Should we do more, or that's fine? Are we good here, or we should do a bit more? One more? Let's do one more. Let's try to come up with something. Let's do 2 more. Okay, find the limit as x goes to infinity of x sine 1 over x. Let's do that. Let's look at this. This should be very straightforward. Well, not very, but should be not bad. First, I try to plug in. Where does x go to as x goes to infinity, infinity, right? Sine 1 over x, where does it go to? Sine of 0, which is 0. I have an infinity times 0. Can I determine what infinity times 0 is? Everybody. Infinity times 0 is an indeterminate form. So I have a form of infinity times 0. It's an indeterminate form. Great. Now what do you suggest doing? Let me rewrite this expression in a nice way. This is equal to the limit of sine 1 over x. Now we know that multiplying by x is equivalent of dividing by 1 over x, isn't it?
Yeah.
Everybody, we good? Great. Now 1 over x, where does 1 over x go to as x goes to infinity? Everybody? 0. Sine of something over the same something as this something goes to 0. What is that? 1. You guys see this? This is just 1. 1 since limit 1 over x is 0, and limit, let's say theta goes to 0 of sine theta over theta is 1. Okay. Are we good here? Awesome. Great. Now, let's move on. Let's move on. What do we have to do now? Let's see what... I did the derivatives, right? I did derivatives. Okay, great. Awesome. I did the definition. Great. Okay. Okay, I think this solves most of your web work questions, right? I think we've covered a lot of your... I didn't have the chance to look at the web works, but all the trigonometric limits are of this form that you have, right? Is there anything more difficult than this, or just that? It's just this? Yeah? Okay, great. Awesome. Okay, great. Awesome. Let's move on. Now let us use some derivative rules. Yes? You had a question? Everybody, yeah? How did I go from here to here? Okay, you're multiplying by x. I mean, let's do it one way. We agree that this is x to the negative 1. Right? Yeah. Okay, so what is that? This is just sine 1 over x to the negative 1. Okay? Yes. That's one way of doing it. Okay? Any more questions on this stuff? No? Great. Yeah. Guys, you can't use the discrete theorem. Let's see if we... No, I don't think so. No, I don't think it works. So you want to bound discrete theorem by what? You want to bound sine 1 over x by 1 and 1 and minus 1, right? Then you will get minus x, because x is positive, you will get that x sine 1 over x between minus x and x. The two limits are minus infinity and plus infinity. So you cannot, okay? Okay, great. No more questions? That's good? Let's look at the derivative rule. Let's look at, so thus far we have seen one way of computing derivatives, which is using the definition. Now, using definition is not, well, I mean, it's very important. We should not do this. But also we can use it to find the properties of the derivative. So if I have a sum of two functions, what is the derivative of the sum? If I have a product of two functions, what is the derivative of the product? If I have a quotient of two functions, what's the derivative of the quotient? So if I have a polynomial, what's the derivative of a polynomial? So the definition of the derivatives will be used to, find, if you will, formulas that are going to help us in finding the derivatives. And using those formulas, we will be avoiding, repeating the definition every single time. Okay? So let us first start with one thing. Let f and g be differentiable. At a point A, let's say, well, let f g be differentiable. Let's say at an arbitrary point x, that's fine. What can I say? Well, then f plus g is differentiable. And f plus g prime of x is equal to f prime of x plus g prime of x. Okay, so far maybe this doesn't have many applications because we don't know any formulas. But let us prove this. Should we prove this or let's prove that. Let's prove that. What is the derivative of f plus g at the point x? This is just the limit as h goes to 0 of f plus g of x plus h minus f plus g of x over h, right? Now what is that? This is the limit as h goes to 0 of f of x plus h plus g of x plus h minus f of x minus g of x over h. Now let me split this into two parts. I mean, it's clear for you that it's going to be the limit as h goes to 0 of f of x plus h minus f of x over h plus g of x plus h minus g of x over h. Now the first limit, what is it? fx plus h minus fx over h. As h goes to 0, what is this? This is f prime of x. You see that? The first limit is f prime of x. The second limit is g prime of x. You guys see this or not? Yeah? I'll do it quickly. This is just f prime of x plus g prime of x. Is equal to f prime of x plus g prime of x. So f plus g is differentiable. At x, and f plus g prime of x is f prime of x plus g prime of x. Okay? Great. Now let's do one more. Of course, if I multiply f by a constant, then the derivative does not change. Let's see the constant. Then Cf prime of x is equal to Cf prime of x, and let's prove this. This is very quick. So the limit as h goes to 0 of C f of x plus h minus Cf of x over h is equal to what? Is equal to the limit as h approaches 0. Let me factor in T out of C f of x plus h minus f of x over h, which is just equal to C f prime of x. Okay, great. So I have two rules thus far. Maybe I'll write them there. I have f plus g prime and f prime and g prime, and I have t times f is t times f prime. T is a constant. Now, using these two, you can determine that f minus g prime, or we proved it from the beginning, that's fine, is f prime minus g prime. Great. Let's do one more. Well, that's fine. That's good for now. And let us try to find out what the derivative of a polynomial function or of a power of x. I mean, of course, we won't be able to do it entirely rigorously, but we will, we will try to do it by example. Of course, if f of x is constant, k is a constant. What is f prime of x here for any x? F prime of x can just be the limit as h goes to 0 of f of x plus h minus f of x over h, which is just the limit as h approaches to 0 of f of x plus h is k. So if f of x is k for all x, then this is just k minus k over h, which is just the limit as h goes to 0 of 0 over h, which is just 0. Now let us look at f of x is equal to x. I think we did this one, right? What is the limit? So f prime of x, no, let's look at here. This is 1, 2. So f prime of x is equal to 0 if f of x is equal to k. Now if f of x is equal to x, I can do the same thing, right? I think we've done this one. if f of x is equal to x, the limit as h going to 0 of f of x plus h minus f of x over h, what is that equal to? F of x plus h minus f of x over h, this is just the limit as h goes to 0 of x plus h minus x over h, and what is this limit? This is just equal to 1, right? X plus h minus x over h is equal to h over h, which is equal to 1. We see that? Yeah? See that? Everybody, we see that? So if f of x is equal to x, then f prime of x is equal to 1. Okay? Any questions? Yeah?
Isn't that a minus k over h? Isn't that indeterminate?
No, it's not a determinant because the numerator is identically 0. Right? You have 0 over h. The function 0 over h is equal to 0.
Oh.
Okay?
Right.
Is that clear?
Yeah.
Okay. Great. Yeah?
Sorry. So when you plug in k for the limit notation for the integral thingy there,
Yeah.
where does that plus h go?
Okay, so f of x is equal to k for any x. So what is f of x plus h? K, right? Okay? Wherever you have x, you replace x by x plus h. Does it matter here? Okay? Great. Any questions? Maybe let's do one more. Let's try f of x is equal to x squared to see what happens. If f of x is equal to x squared, f of x plus h minus f of x over h. I mean, do you think we can do that a bit fast? Let's try to do this fast. This is x plus h squared minus x squared over h. Try to plug that in. You get 0 over 0, of course. This is a 0 over 0. And then what do you get? How do you suggest doing? How do you suggest returning it? We can expand the square, right? Or we can factor it. Right? The difference of two squares. Okay? Do you guys see this or not? These are easy limits, right? This is the limits we've seen at the beginning. So let's see. Let's try to do it by just looking at it. What do we have? We have x squared plus 2hx plus h squared, right? Minus x squared. So what do I get on top? I get 2hx plus h squared, right? Over h. 2hx plus h squared over h. Did I get rid of my 0 over 0 or it's still 0 over 0? It's still 0 over 0, right? Everybody? What do you suggest doing here? I factor an h out from the top and then cancel it with the h on the bottom. H 2x plus h over h. So it's the limit as h goes to 0 of 2x plus h, which is just 2x. Okay, so if f of x is x squared, then f prime of x is 2x. Okay? Now there's a rule that you can see. If you have x to some integer power, so if f of x of a positive integer power, we'll see the other one later. If f of x is x to the n, then f prime of x is n to the xn minus 1. Let me double check if the book states it for just for integers or for every single one? Oh, okay, it does it for every positive, okay. For any positive integer. That you can show easily, more or less. And there's a slightly harder one, well, not slightly, it's a bit harder. If n is a real number, where n is a real number, then also f prime of x is n x to the n minus 1. Here, of course, I have to worry about the domain, right? The domain of f, if x is a negative number, for example, x to the minus 2 is not defined everywhere. Okay? So things like that we have just to, we will not worry about for now, but just to pay attention that if f of x is x to the n, then f prime of x is n times x to the n minus 1. N is a number. Okay? N is not a function of x. N is just a number. Okay, enough said now. Let us try to do some examples. Great. Example, find the derivative. Okay, great. First of all, I'll pick them, maybe I can do some examples from the book, I think. This is section 3.1, I think it's page 181. And let us look at question 4. It says find g prime of t if g of t is equal to what is g of t? 5t plus 4t squared. Okay. So g of t is a sum of two functions, right? Everybody, do we agree? G of t is a sum of two functions. So g prime of t is just 5t plus 4t squared prime. Now, what do I know about the derivative of a sum of two functions? It's the sum of the derivatives. You guys see this? F plus g prime is equal to f prime plus g prime. So I have to differentiate 5t, and then I have to differentiate 4t squared. Now, what do I know about the derivative of a constant times a function? It's that constant times the derivative. You see that or not? So this is 5 times t prime plus 4 times t squared prime. Great. Now I have a power of t. What's the derivative of f of t is equal to t? It corresponds to n equal 1, right? F prime of t in that case is just 1. Now if I take t squared, so x squared, what's the derivative of x squared? You bring the n down and you lower the power by 1. So you have 2 times x to the 1. So let's do it this way. And so what do you get? You get 5 plus 18. Okay? Are we good? Everybody? Yeah? Yep.
On an example, we have to walk. Can we just use the
No, you can use it. You can, I mean, let's not worry about the exams now, okay? I mean, we'll see, okay? It's in a month, okay? Yeah. Guys, for now, yeah, okay? Any questions? Guys, any questions? No more? Let's continue. 7/4 squared minus 6x plus 12. Let's find this derivative. Let's find this derivative. Maybe, should we try to do it a bit faster or not? Can you do it a bit faster? Yeah. Okay. Should we do more steps? What do you guys prefer? Faster. I think some people want more steps because... Okay, let's write more steps. So G is the sum of how many functions? Everybody, G is the sum of 3 functions. So the derivative of G is the sum of the 3 derivatives. You agree? So the derivative of G is the derivative of 7/4x squared minus the derivative of 3x plus the derivative of 12. Great. Let's look at this. What's the derivative of a constant? If c is a constant, I erased it. But the derivative of a constant function is what? 0, right? So if I have a derivative of a constant function, the derivative of 12 with respect to x is 0. Great. What's the derivative of x here? The derivative of x is 1, right? If I sum by 3, the derivative of a constant times x is 3. Now, what's the derivative of 7/4 times x squared? It's 7 times 4 times the derivative of x squared. What's the derivative of x squared here? 2x. So what do we get? We get 7/2 x minus 3. Okay? Now let's look at the derivative of x to the minus 5/2 minus x to the 3/2. What do I see here? What's the first thing I reason? How do I reason? What's the first thing I spot? It's a sum of 2 functions. So the derivative of g is the sum of g's 2 derivatives. Or let's put a 5/2 here, okay? Great. Now, where does this appear in my derivative rules? Let's look at this. X to the minus 3/2, x to the minus 5/2. How do I differentiate this? I try to use this law, right? What's the derivative of x to the n? It's n times x to the n minus 1. What is my n in this case? My n is minus 5/2. So I have minus 5/2 times x minus 5/2 minus 1. Then I have a minus. What's the derivative of x to the 3/2? It's 3/2 times x to the 3/2 minus 1. what do we get? I get minus 5 over 2 times x to the minus 7 over 2 minus 3 halves x to the 1 half. Are we good? Are we all good? Okay, let's do one more. Let's look at g of t is t squared plus root t. How do I proceed here? T to the 1 over 2, thank you. So, it's g of t here, sorry. So how do I proceed here? Your friend suggested that I transform the root t into a power. What is the power of t that gives me root t? T to the 1 half. So g of t is t squared plus t to the 1 half. Great. Let's do it quickly now. What's the root of g? What's g prime of t? These are the sums of two powers of x, right? How do I differentiate t squared? Everybody, guys, how do I differentiate t squared? How do I differentiate t squared? I bring the 2 down, and I lower the power by 1. So I get it's 2t plus, how do I differentiate t to the 1 half? I bring the 1 half down, and I lower the power by, so what do I get? It's 1 half times t to the negative 1 half. Okay. I will try not to read this. Okay, now maybe a lot of people know the term for this rule. This is called here the power rule. Okay, this rule here, this is called the power law, or the power rule. Power. Anyway, great. So far so good. Okay. Okay. Let us do what the derivative of one more function, which is the exponential function. Okay, now let us try to find the derivative of e to the x. Okay, how do I proceed? By the way, how do I proceed here? Guys, everybody, are we all good now? Yeah? How do we proceed here? If I want to find the derivative of something and I know nothing, how do I start? By looking at the definition of the derivative. So what do I have to look at? I have to look at the limit as h equals 0 of f of x plus h minus f of x over h. What is that equal to? This is just e to the x plus h minus e to the x over h. Now, what do you suggest doing here? What do you suggest doing? What do I know about e to the a plus b? E of a plus b, what is that? I can factor that, right? Well, I can, not factor, but I can use a exponential rule. This is just e to the x times e to the h minus e to the x over h. Now I can factor e to the x. Great. Does x matter in the limit? Does e to the x matter in the limit? Everybody? No, e to the x doesn't matter in the limit. What is the thing that matters? it's e to the h minus 1 over h. Now we'll take this for granted that this limit is equal to 1. E to the h minus 1 over h. We will assume that the limit as h approaches 0 of e to the h minus 1 over h is 1. Okay, and this limit really defines the number e. So if you put any other number than e, the limit will not be 1. So this is, you can take this as the definition of e. So what is this limit? This is just e to the n. Remark? E is the only positive number that satisfies e to the h is equal to 1. And I mean, if you have any, in fact, the limit as h approaches 0. In fact, if a is positive, the limit as h approaches 0 of a to the h minus 1 over h is equal to ln of h. Okay? We'll take this for granted. Of course, we will not. You won't have to prove this, but these things we will take for granted. That h to the h minus 1 over h goes to ln a. Now, what is the only number that makes this limit 1? You have to solve ln a is equal to 1, right? So a must be equal to e. Just let me double check this ln a. So e of ln, yeah, okay, yeah. Okay? Any questions? Okay, I think we've done a lot today, so let's call it a day.